Ladies and gentlemen, welcome and thank you for joining today's web conference, Data Transferability Process for Marine Renewable Energy. With that, I'd like to turn things over to Andrea Copping, Senior Scientist for PNNL's Coastal Science Division. Please go ahead.
Thank you, Tegan. Good morning, everyone. This is Andrea Copping at Pacific Northwest National Laboratory, and I'm here with my colleagues, Michaela Freeman, who many of you have communicated with, and Alicia Gordon. Very pleased to have you here today on this webinar where we want to talk about our data transferability process for marine renewable energy. As the AT&T operator told you, your lines are actually open, hopefully muted, but open. So please feel free to ask oral questions as well, or stop me if there's something that could do with a little more explanation. We're really interested in your interaction, your feedback, and so on. Today, what we're going to do is just talk a little bit about the purpose of this webinar and the topic, and I will apologize for those of you who have joined us on previous webinars. We are going to rehash a little bit of ground we've been over very briefly, just as the background, particularly for those who haven't been with us before, and to set the stage. We are interested working, as I said, specifically with the regulatory community. We work with many other communities around marine energy, particularly developers and their consultants, researchers, and so on. But today we really are interested in what the regulatory community thinks. And we're going to talk about our data transferability process, consisting of several parts. We have a framework and project archetypes, best management practices, and we'll sort of wrap it together with an implementation plan we are proposing and talk about what happens next. So just for background, the reason that we are engaged in this is to try to look at barriers that have slowed permitting of marine renewable energy development, specifically wave and tidal, though clearly offshore wind falls in this category as well. We hear from the marine renewables industry that they feel it takes a very long time to get projects in the water, that permitting is long and complicated. They really would like to be able to avoid or decrease the amount of both baseline and post-installation monitoring data that are collected, and that everyone is a little bit afraid of what mitigations could be looming in future. At the same time, from speaking with the regulatory community, we really understand the challenges you're facing. There aren't a lot of devices deployed around which to gather data. These are, to the most part, new technologies, particularly in the ocean environment, and we really have a lot of uncertainty around marine renewables and environmental effects. We recognize that as the regulators and policymakers for your agencies, your job is to protect the marine environment, to follow all federal and state laws, but at the same time you have considerable pressure to make decisions in a timely basis on applications coming to you. So we really firmly believe that the way forward is to have more deployed devices and learn as we go. Now, I've been saying we, and for many of you may be aware of this, but this project is really a part of the Annex 4 collaborative task under ocean energy systems. We have 12 nations that are collaborating together to try to understand environmental effects of marine renewables nationwide or worldwide. And this past year, 2018, we've really been focusing on this idea of data transferability. So what we mean by that is using data from already permitted or consented marine renewable energy projects. We also are very interested in learning from analogous industries where there is learning, data, information that can be transferred to help inform potential environmental effects and permitting of future marine renewable projects. But to pause for a moment, what do we mean by data? We don't necessarily mean raw data. We mean it could be quality assured data, analyzed data, synthesized data, really the creation of information and the sort of information that you as regulators would receive in permitting applications. These may be reports or various other sorts of synthesized data. And in working with the marine renewable energy industry and other stakeholders over the last number of years, it has become clear from permits in Europe, from processes in the US and Canada and in Asia, that there are certain interactions or potential environmental effects that really rise to the surface as being most important. And we have focused on 6 of these. And you'll see them listed there. Collision risk, which is mostly about in the water, it's mostly about tidal devices. For those of you that are very engaged in offshore wind, obviously there's collision risk of flying things, birds and bats as well. We're not really addressing that today. However, we believe these principles and processes apply equally well. Underwater sound from devices, the potential to disrupt and bother marine animals, electromagnetic fields from electrical cables and energized devices, changes in habitats, displacement or barrier effects. This isn't something we've dealt with a great deal worldwide because it becomes something much more important when you have multiple devices in the water, as they have offshore wind turbines in Europe. But in the wave and tidal sectors, it just hasn't really been much of an issue yet. But we think it will be, or it may be in future. Then changes in physical systems. That's changes in circulation, wave heights, and so on. So we have been working with regulators in the U.S. particularly with several webinars that were held last year, and we did put out a survey that I suspect a number of you responded to. And this year we did delve into the literature and write a white paper on this idea of data transferability and collection consistency, particularly learning from other industries, other interactions. We held a series of webinars based on regional areas, both in person and online, with regulators, state and federal, throughout the country. And this last June, we had a workshop where we brought together experts. It was associated with the International Conference on Ocean Energy, or ICOE, which was held in France in June. And we really focused on this data transferability framework, best management practices, and implementation plan. And that's part of what I want to talk with you about today. The survey we did with regulators in the U.S. really tried to focus on this idea of data transferability. We also really wanted to understand how much knowledge regulators had around specific technologies, specific interactions, so that we can tailor some of the work we do for that. What we found was that varying degrees of knowledge. We also shared some some example data that had been collected around wave and tidal devices. I'll show you a smattering of that in just a moment, and tried to understand regulator needs and their willingness to share data. And that little graph up in the right-hand corner really gave us heart that when we asked, what is your willingness or your interest as a regulator in taking data or information from already permitted projects and applying it to your applications? And what you see is there was a real interest between both state and federal regulators that this really ought to be done, maybe, or absolutely. And then we also asked you about the framework such as we had it. These next couple slides are just sort of examples of some of the information we showed at workshops. For some of you, this may look familiar. The video is the turning that's the voice turbine that was deployed up at the European Marine Energy Centre in northern Scotland for a while. And this is really trying to get across the idea that these blades turn slowly. They're very different than conventional hydro turbines or ship propellers. And also you see a bunch of fish there that really aren't bothered by these turbines. So that just gives you a little bit of an idea. And that is a malfunctioning turbine in the lower right, or camera, lower right side. That's the device there right below it. I'm not sure in play. Can you try that? I'm not sure you'll hear that. We also played the sound out of a turbine. That's the Open Hydro Turbine on its research platform, also at EMAC, and apparently it doesn't play over the web. Sorry about that. And the point here really is looking at what that sound spectra from the operating turbine would look like, and probably most important that the highest amplitude or decibel level is below action levels as they currently exist for both marine mammals and fish. We also showed you a little bit of, will that video play? There we go. A couple of the wave energy devices, wave energy converters that have been deployed at the Wave Energy Test Center in Hawaii. That's the Fred Olsen toroid up above. on the left, and then you have the Azura wave device both above and below water on the right. Not moving very much despite the waves. And then the colorful, weird-looking thing in the lower left is the a sound print from the Azura device. And we won't go into the details there, but you get the sense that these sound spectra over time are complex, but again, we saw that the amplitude did not exceed levels of concern for either marine mammals or fish. Okay, come on. Okay, so that really brings us to the data transferability process that we have developed, and some of you may have heard bits of this, but not all of it. Now, this diagram here is our best illustration of where we are, though we're always open to having people tell us there's a better way to visualize these things. If we start in the middle, the framework, the big orange blob, is really how we're trying to look at data sets of already permitted projects and the future projects that you are likely to get applications for, how we classify those, how we look at them. And we'll get into that in more detail. On the left, the data collection consistency table, the overall sense being, if you are going to compare data sets or information, you have to understand how the data were collected and some sense that you are comparing apples to apples, oranges to oranges. Get into that a bit more. On the right-hand side, still under development, is the Monitoring Datasets Discoverability Matrix, and we're open to a better name there, by the way. This will be an organized sorting and storage of data sets that have already been collected around permitted devices and arrays. And the idea is that from the framework, you'll be able to query this matrix and discover the data sets that are similar and transferable, if you will, to what you are looking at. Around it, in the dotted line, we have developed a simple set of best management practices to really sort of operationalize what would this look like if you tried to apply this framework and the data consistency and the matrix. And then all around that, an implementation plan, which is really what we will be following as a blueprint of how to operationalize these BMPs through this process. So you're going to see this diagram come up several more times, because what I'm going to do is walk through these pieces, starting with the framework. So the framework, the purpose here is to develop a common understanding of the kinds of data, parameters that you would want to collect to best address potential effects of marine renewable development. And from this, we can create a set of best practices for how we would consistently collect data that are comparable enough for transfer. The framework itself consists of a method of describing the environment and evaluating the comparability of these data sets. And we've called this Marine Renewable Energy Project Archetypes, an archetype being a very typical example or an imitation of the original, if you will. We've described how you'd apply the framework and then talked about some methods for how this might help you as you do your regulatory processes for evaluating applications. This is an example of one of those marine renewable energy archetypes. In each case, the archetype is defined by 4 parameters. The first is the stressor, and I showed you those 6 stressors that we've examined to date. I've just picked one here, underwater noise, and then we characterize an archetype by the overall site conditions, the technology, the MRE technology involved, and the receptor. So in this case, for underwater noise, we've divided site conditions into sort of quiet environments, more isolated, or noisy environments. And we've used that cutoff, isolated or quiet to noisy, to be 80 decibels broadband. We might have noise coming from a tidal device or a wave device. And the key receptors for sound, of course, are marine mammals and fish. So in order to think this through and define an archetype, we might say, okay, our stressor is an underwater noise, looking over on the right-hand side, and the application we're looking at is for a pretty noisy area. Maybe it's Puget Sound with a lot of commercial shipping going by or some such thing. The technology that the applicant is interested in is a tidal device. The receptor of concern are marine mammals. When we put those 4 sets of parameters together, we have defined a project archetype, so that as we go looking for other data sets to compare, that's what we're trying to compare to. And we've developed a set of guidelines for this transferability, starting with what we think is really important, and that is that you have this same marine renewable energy project archetype, that you're comparing like to like. It's important that you have the same project size. Is it a single device or is it an array of devices? And the one caveat or disclaimer here is that early on, we don't have many arrays, especially of tidal and wave devices, so that we may need to look at effects of some of these stressors around single devices and try to make some estimates of what would go on around arrays. Later on, we hope that there will be many more arrays and data sets that will be sort of comparable array to array. Next, the same receptor species. It's got to be a closely related species. If you have an application and the concern is gray seals and you find data sets associated with harbor seals, there may be some learning that can be transferred there. But if you only have data sets that deal with humpback whales, that is unlikely to really inform your potential risk to gray seals. So that's what we mean by the same receptor species are closely related. Similar technology, not only does it have to be the tidal device to the tidal device, wave device to wave device, but each of those technologies, of course, comes in many flavors, particularly in wave. So it would be best if you had information around a point absorber wave energy converter that was comparable to another point absorber or type of point absorber. But that may not always be possible. You may be looking, and it may not always be necessary, you may be looking at animals reefing around or turtles reefing around a oscillating water column as being very similar to that of a point absorber. So there's some judgment needed there. And finally, it's nice if you have a similar wave or tidal resource. For example, if you have an application for a tidal device that will go into an average 1 meter per second current, tidal current, it's probably more comparable to another data set with around a 1 meter per second tidal current than something with a 5, 6, 7 meter per second tidal current. But what you see on the guidelines for transferability along the left-hand column, we think starting at the top, it's really necessary. You're very closely related in the Marine Renewable Energy Project archetype. And as you go down that list, it's important and nice to have by the time you get to the bottom. As we get more and more data sets worldwide, perhaps it's possible to be more rigorous in matching up every one of these. But we're trying to look at that sort of process as we go along. And we do see all this that we're telling you, these processes, as living documents, as living processes that can be proved upon, tweaked, et cetera, as we go along. So I'm just sort of punctuating there because a number of you have seen a good deal of this before. We're doing some reorganizing and so on. But we did get a pretty strong signal when we talked to regulators in the U.S. and in other countries that generally regulators are not looking for raw data. They are looking for information, synthesized data, analyzed data, et cetera. We got very good responses from showing video and audio clips of what's really going on underwater, especially for some of these really thorny interactions like collision risk around tidal projects, because there's really no good analog. We're told in a number of different ways it's helped increase understanding of potential effects. And overall, we got pretty good feedback on what we've been looking at with the framework. And we did, in the first iteration, get very strong feedback that regulators would like to be able to have an easy way to discover data sets that are comparable, which is what that matrix of data sets discoverability is about. So that was sort of added to the process based on feedback. Okay, so moving on, other parts of this data transferability process diagram, the data collection consistency table. Now, I think we're realists that there is no way that regulators in this country or anywhere are going to be able to dictate worldwide that everybody must collect data through a set methodology, set instrumentation. So So I think the best we can do is really ensure the data are collected consistently in terms of units, the processes are very transparent, and so on, and that there is quality assurance done on all data. Why don't you add that table? This is just the initial table we started with the experts at our workshop in June, and we are tweaking and are looking for all kinds of input on this table. And this only includes 5 of the 6 interactions I mentioned. But you see on the left-hand column the stressor or interaction. The process or measurement tool, this lists what the most common ways that these interactions are measured at the moment. We've tried to sort of bound the reporting units and a little bit about analysis or interpretation. So just taking an example here, collision risk. Generally speaking, people are looking at collision risk around tidal turbines using acoustic information, sometimes passive, but generally active acoustics, sonar, echo sounders, etc. Also using video cameras, sometimes triggered one to the other, etc. The reporting units, obviously a collision would be the key reporting unit, but it's also become very important to just report how many visible targets are seen within the field or in close interaction with the device. And sometimes for fish, even if fish are in close proximity, it's pretty hard to tell whether a collision has occurred unless there's real, fish parts or dead fish, etc. So what would you do with these data once you collected them? In terms of analysis and interpretation, what we would like to do is take the number of collisions or interactions or whatever you want to call them and use them to validate collision risk models. There are a series of these models in existence. Some of them are being used for regulatory purposes in Europe, though everyone agrees they're poorly, if validated at all, and there is certainly room for improvement. The collision risk models being used around tidal turbines right now are adapted from bird collisions with land-based wind turbines, and there are some fundamental sort of differences and problems with those. Anyway, you can see, and you'll get access to these slides after. You can look at each one of these and sort of think it through and provide us feedback on how we can improve upon those. And it's interesting because when we had our workshop with our experts, we had quite a long discussion that went round in a circle that we needed to be much more specific and subdivide each of these topics, and it came back around to, no, wait, you get yourself into a position where you become too specific and you cannot allow for new types of devices, new types of measurement techniques. So we're still really working on this to find the best possible fit. Okay, the monitoring datasets discoverability matrix. Now, this is just under initial development now, but what it will attempt to do is classify existing datasets using these marine renewable energy project archetypes. And that'll include the list you see there, the stressor receptor, the size of the project, single device or array, what technology, site conditions, etc. And that will eventually become an online tool where you can simply go in and choose your, drop-down menus, we think. We haven't designed it yet. Probably drop-down menus where you will pick your site conditions, your stressor, your project size, etc., and discover those data sets. And this is how we believe this, going back from the framework, querying for data sets, bringing those data sets back for comparability. We think this will help. And it will eventually be hosted on TSIS. Now, the next thing we thought of, things have seemed fairly theoretical up to this point. We've really wanted to see how we can operationalize this. And I think many of you are probably familiar, I'm sure all of you are familiar with the concept of best management practices. As we went back and delved into the literature, this really was a term coined, I'm not sure the concept was really coined here, but by the U.S. Environmental Protection Agency in the 1990s, and very briefly defined as a practice or procedure that is qualitative and flexible. So this is really the practical application of how you would go about using this. Best management practices are generally considered to be worked through 3 phases, a planning phase, a development and implementation phase, and an evaluation and reevaluation. Think of this as very much feedback driven. In our terms, the planning phase really was the series of workshops and the whole data transferability process, thinking about what should be achieved, and then the best management practices is how we might get it done. In terms of development and implementation, we have drafted best management practices and an implementation plan. We did discuss this with our experts at the workshop in France. And then once these are underway and being applied, that's when we think that an evaluation, reevaluation phase has to happen on a continuing basis. We have developed 4 fairly high-level simple BMPs, and they should be fairly obvious. The first being, if you want to transfer data, that is, find data sets from permitted projects that are useful to your applications, you need to meet the minimum requirements. That's those guidelines for transferability in the marine renewable energy project archetypes, that sort of listing with the arrows I showed you, in order to consider using or transferring this data. So the reason for this is so that we meet these minimum thresholds that will show that the data sets are comparable or similar enough for transfer. The second BMP follows right along there, is once you have a data set that seems like you could, quote, transfer it or use it to learn from, it's important to understand that it's meeting data consistency needs and quality assurance requirements. So that means that that's really to ensure that you're comparing these apples to apples, oranges to oranges. And the way we would go about that is by taking a data set, going to the data consistency table, comparing the data set you have from the consented project and how you already have data collected perhaps by a developer, or how you would ask for data to be collected in the application process, the project under application. And that's why this data consistency table becomes really important, and we need to continue to work on that. Okay, the third BMP is the use of models in conjunction with or eventually replacing some data set collection. The obvious point here is that numerical models are a key piece of understanding how processes exist, and for all of you who regulate in other application spaces in marine energy, I think this is probably very obvious to you. Just to take it back to sort of first principles, you can't really create models of interaction until you have enough data to understand that interaction. And in much of the marine renewable energy space, we aren't there yet. But as more data are collected, and once there's sufficient data to exist for an interaction, again, let's think about, say, underwater noise. What do we understand about how animals receive noise? What do we understand about the soundscape that will be put out by a device? We can begin to model that. And as we do that, data collection efforts should be able to drop somewhat and really be focused on validating and improving those models, showing that the model, the simulated version of the world out there, is correct. So for each model that you do use, there are some minimum requirements. You need to know something about what model you're using, what's the name of it, what's the version. Has it been validated with field data, and if so, how, where? And what are the major stated assumptions and limitations? Probably the greatest faults that are found with modeling in the environment are that often assumptions and limitations are not adhered to, and models are applied where they really shouldn't be. So it's important to get enough sense. You don't have to become modelers yourselves, but you do need to understand assumptions and limitations and how they should be applied. Our fourth BMP is to be able to provide context and perspectives for those data sets you want to transfer. This really, we believe, helps apply available data sets that are pertinent to the application you're looking at and helps explain what you're seeing in those data sets. So how would you go about doing this? If an area where you have a marine renewable energy application, it's important to look for, or perhaps you tell the developer and his consultants to look for, other data sets in that area that are pertinent. For example, behavioral studies of animals. If you want to understand what the collision risk to marine mammals are around a tidal turbine, it's important to understand, if possible, how those animals are likely to react. it would be good to know something about the hydrodynamics and wave climate of a site and the surrounding areas, so you understand, for example, if fish are likely to be entrained in tidal streams and unable to stay away from the devices. Habitat maps of an area, not just the actual footprint of the project, but the larger areas would be very important too. But I do want to note, we're not in any way saying these are the sorts of data sets you need to require a developer to collect. I think this becomes a very endless kind of process. But if there are data sets existent, it's really important to gather them, evaluate them, and use them in your perspective. Sorry.
There's a question.
Oh, sure. Yeah, go ahead, please.
So from Heather Sagar, she'd like to know if we have collected the data in the Ocean Policies data portal or from marinecadastre.gov, and that's a joint effort between NOAA and BOEM.
Thank you. We are very familiar with both those data portals, of course, and this is exactly on point. These are the kinds of data sets that when you, for example, provide guidance to a developer in putting together an application, you should point them to those data sets. We will not gather those background data sets into the data portal, the Discoverability matrix. We will simply be dealing with those data collected around permitted devices. But those are exactly the kinds of data sets, Heather, that we think are incredibly important. And on TESIS, we already have pointers to those portals and many others. And as we go through this process and put an online tool up, we will make sure that those are included there. So thank you. Very good point. Those are the kinds of places you go find these. So that was a quick once-over in the data transferability process, and it's probably no surprise to you that every one of these pieces I've talked about there is a report on. So there's more than you'd ever want to read, but that'll be available before too long. So in terms of this data transferability process, obviously we have a fairly strong belief here from the people that we've interacted with here in the U.S. and in other nations that this is something that could help move marine renewable energy applications and permitting along. And obviously it's to the benefit of the industry. We hope it is to the benefit of the regulatory community, just making some tools and data sets and so on available to you. And I want to stress that this is only going to work if you, the regulatory community, are really on board and engaged. We see your involvement as essential. We really hope that you'd be willing to accept this whole premise of data transferability and be willing to apply these principles and collection of both data transferability and collection consistency as you evaluate applications. But this is why it's so important to us that you provide feedback, that you tell us what you think works and doesn't work, where we're missing the boat, where we can improve upon things, etc. At the same time, we feel that all the community around marine renewable energy needs to be engaged. Device and project developers, we are working with them as well, and we have a strong need that they recognize the value of this process and that they will commit to collecting and providing the data that are consistent with these guidelines so that you will get on the first instance with applications what you need. And we see that as really being a good feedback, providing more data that can be put into this database, datasets, discoverability matrix, et cetera, building on itself. Similarly, the researchers and the consultancies, we want them to be well aware of this process, and especially things like data consistency requirements, so that the data they collect, be it monitoring for the device developers around their devices or in research studies, is also consistent and can be added to this body of knowledge. Okay, the last piece of this process is this implementation plan, and we have written a draft of that plan, and we're going to be improving upon that over the next month or so, and then this will be a very key feature of next federal fiscal year's work for us, October on. And what we are trying to set as sort of needs and goals in that plan for supporting the regulatory involvement is we want to ensure that you have access to these data sets and processes we've talked about. We want to assist you in applying this process. We'll have an active outreach and engagement program, and again, we're looking to you for the best ways to work with you and your colleagues. And we want to be able to provide technical assistance to help implement these best management practices. Similarly, we will be working with the device and project developers to make sure they're aware of this process. Same with the researchers and consultancies. Again, we go to the research community for help in understanding whether we're doing the best we can with the data consistency. Are there better new techniques or ranges of data collection that really make sense. So we'll be working through this implementation plan with all those groups. So in terms of next steps, and there's our next, that should have been FY19, my mistake. The new fiscal year that starts in October, we will be implementing this plan. We are going to continue to seek input from the U.S. and regulators and those in other Annex 4 countries. We have piloted all this in the U.S., but the other Annex 4 countries, 11 other countries, are starting down this process. Many of them have provided the same regulator survey to their regulators to understand the state of knowledge around technologies and the interest and engagement in this data transferability process, and they will be following along on this. It happens that the U.S., being such a big country, we have rather a lot of state and federal regulators along the coastal and Great Lakes and other states who will be involved with marine renewable energy. In some of the smaller, say, European countries, there are far fewer regulators, so the way this will be done will differ some. And then we have strong ties, of course, with other countries that are somewhat further along. For instance, the UK, with the developments up in Scotland, in Wales, and in England, we have a lot to learn from them, as happily we now have things to teach them as well. So this is really going to go on and really bloom through the Annex 4 countries. As I said, eventually everything will be up as web-based tools on TSIS. Now, there's one other concept that has come up through the process of this and some other work we've done with Annex 4. There has been an interest expressed in bringing together groups of regulators from different countries to really see where there can be some good learning moved back and forth between them. Now, obviously, every country has its own sets of laws and regulations, but overall, the concepts behind those laws and regulations in protecting the marine environment and the animals and so on are very similar. And so we are looking to perhaps bring a group together. Obviously, travel is kind of a problem, so we're talking about an online virtual group. And at the same time, there has been an interest expressed in doing maybe semi-annual updates on what the state of monitoring technologies, monitoring outcomes, et cetera. And so we think that there's some real synergies there where there may be interest from the regulatory community in different countries of understanding sort of what the latest state of the science is, what some of the big breakthroughs we're seeing are, et cetera. So we are going to look to putting that group together. All of you will get an invitation. I'm hoping that might be of interest to you to get on, an hour or so every 6 months or so to both interact with other regulators, but also perhaps hear some presentations from the research community, from monitoring outcomes, et cetera. So that's something to look forward to. Okay, I've talked about a lot of these data transferability process pieces. There is a page on TSIS. You see it at the bottom of this slide. It's just tsis.pnnl.gov data-transferability. And all of the various pieces I've talked about are up there. This is, by the way, not a page you'll find by searching through TSIS very easily because we've put it up there really for the regulatory community. So you need to have that /data transferability. And you'll find the various links to the webinars that we've had before now. This one will go up as well. You'll find the white paper. There's a workshop recording from when we did online meetings earlier. And you'll also find documents from the workshop that we held in France with the experts. So I hope you'll visit there. And with that, I need to stop talking. I want to thank you all for taking the time this morning to join us. And what I'd really like to do is answer questions, discussion, comments, really like to know what you think and any sort of, feedback, critique, etc. So please.
All right, just as a reminder, your lines are unmuted, so you're welcome to speak up at any time, or you can send your questions in writing using the chat panel on the right-hand side of your screen. Please remember to select all panelists from the Send To drop-down menu before submitting your questions.
Andrea, this is Delia Kelly. Can you hear me?
Yeah. Hey, Delia.
Hi. So for everyone, this is Delia Kelly. I'm the Ocean Energy Coordinator with Oregon Department of Fish and Wildlife. My question is, can you describe a little bit about the feedback that you've gotten directly from developers? My sense is that you might run up against confidentiality or proprietary concerns with sharing data, and the success of the transferability seems like it would be contingent on willingness of developers to participate.
Great question, Delia. And we addressed this considerably at our workshop in France. A couple of things that I think aren't surprising, but we heard there. It's not the developers themselves who are generally dealing with these kinds of on-the-ground data collection and so on. It's their consultants. And we had a number of the European consultants who, quite frankly, the Europeans are less open about sharing data to some extent than we are, partly based on some laws. But we really got a strong sense that for these environmental data, there is quite a good willingness among the wave and tidal developers to share these data. These are not power performance data. These are not data that run into IP issues associated with the devices or even the moorings or anything else. So I think there's a pretty strong distinction there because there is very strong pushback from sharing those kinds of data. Some of you may know that the US Department of Energy, if they fund tests or other kinds of device development grants, they require the data to be made public, but it's usually embargoed for 5 years and so on and so forth. But we are not seeing that with the environmental data. I think there's a real understanding as the wave and tidal sectors and also offshore wind, especially in this country, as they've been slow to progress. The industry seems to understand that sharing and collaborating at this point is going to benefit them all. So it's a good thing to think about, which is one of the reasons we need to work directly with them. So far, we've had pretty good engagement and willingness to participate. Also, I do want to point out that any of the data sets that will be in the data matrix will be those for permitted projects, which means they have become public sector through some government agency anyway. But it's a great question, Delia. And by the way, thank you, Delia, for introducing yourself. And anyone who asks a question, I'd ask that you do that too. So thank you. I do want to reiterate that you will find this presentation soon, and we'll have a video audio of the webinar up in a few days' time once we get that. But you'll find it at this link on TSIS, and you saw our emails and so on that last slide, so feel free to contact us at any point. I'd also like to let you know that on September 25th, we will be holding another webinar, which will be open to not just regulators, but all of the community, which will take us sort of these last steps as we're cleaning up this process for the end of our fiscal year. So it'll be at the same time on September 25th, and so we'd certainly love it if you join us then. I know August is a bit of a tough time. Okay, with no questions, I would like to again thank you for taking the time today. Please feel free to share any of this with your colleagues. And we hope to be interacting with you and having more chance for feedback and discussion in future. So thank you very much for joining us.